Okay. Well, welcome everybody. Keep coming in. There's still plenty of seats. I see some seats over here. Don't feel the need to stand in the back unless you really want to get that exercise during the talk today. But thank you so much for coming out and joining me today. I am so happy to be here. I love being in Prague, so any excuse to come here is always good in my book. My name is Brandon Minnick. I work as a developer advocate at Microsoft. And today we're going to be talking about correcting common mistakes when using async and await in .NET. And this talk was inspired by real-world experiences that happened to me in my apps. I'm a mobile developer by trade, and I kept hitting weird bugs in my apps where all of a sudden my app would be doing things that I didn't expect it to do, and I'm looking at the code, and I'm like, there's no way it would do that. And turns out I just didn't really understand async and await. So at the bottom of the slide here, you'll notice there's a link. That's a landing page I put together just for you. So that link will be at the bottom of most of the slides today. Make sure at some point, take out your phone, snap a picture, because that's where you can find all the materials from today. So that's where the slides are. We will be going over a couple of open source samples. Those are all available to you there. And then also, if you want to dig even deeper into async and await, it is a crazy, crazy complex topic. You can go way down the rabbit hole. We only have an hour, but there's even more links on that site for you to learn even more and then keep drilling down into it. But let's get started. And what I want to start with talking about is just multi-threading, because, well, that's why we do async and await. That's why we write asynchronous code. And I want to start with just looking at the thread pool. And the thread pool is where all of our threads live, and it's how .NET manages everything for us. Like, back before the thread pool existed, if we wanted to run a background task, we had to know exactly what thread we were on. We had to know exactly how to pass that off onto a new thread. We had to figure out what to do when that thread was done. But .NET's got that all taken care of for us, and they do it all in what's called the thread pool. So very fortunate to be in .NET that can do all that for us. And what's nice is there is a maximum number of threads, but it's super, super high. It's actually dependent on how much memory you have. So depending on what machine's running your code, that depends on how many threads you get. But the nice thing is, you never have to worry about running out of threads. Because as you spin up more and more background tasks, if you do happen to run out of threads, I mean, that would mean you're hitting 50, 100, 200 threads. But if you do run out, no worries, because the thread pool just takes those tasks, queues them up. When the next thread is available, it runs it on there for us. So we don't have to worry too much about how the thread pool works. But let's take a look at an example. So this is a pretty simple async task method where we are calling, let's see, it's called read data from URL. We are newing up a web client, WC. And yes, we should all be using HTTP client in our code. But just to keep the example simple, I'm still using web client here, so bear with me. Then after we new up the web client, we called wc.downloadDataTaskAsync. When that's done, it stores that result in a byte array. We take that byte array, turn it into a string, and then we kick off another method called loadData. So what is actually going on here with multi-threading? Well, we start out with thread 1. Now, thread 1 is also known as the UI thread. It's also known as the main thread. It's also known as thread 1. You'll probably hear me use those three terms interchangeably, but thread 1, that's actually what draws all the UI on our screen. So if we're making a mobile app, if we're making a desktop app, if we're making a web app, whatever gets painted onto the screen, that's all done with thread 1. And then on top of that, if the user interacts with our application, if they tap a button, if they scroll the screen, thread 1 is what interacts with the user as well. So thread 1, the main thread, the UI thread, is super, super valuable. And we never want to have it doing anything long running because we want it available to keep up with the user. Because if thread 1 is all tied up, it looks like our app's going to be frozen. And what's the user do? They force quit the app, they delete it, they give us 1 star. It's terrible. So what we do, we call await, and that runs download data task async on a different thread. And in this example, we'll say it's thread 2. Now, it's not always thread 2. It could be thread 17, it could be thread 12, it could be thread 56. But for at least this example, we'll just deal with, we'll pretend like we only have 2 threads available. So download data task async runs on thread 2. And what's nice right here, thread 1 is free. We've freed up thread 1 to go back and do whatever, interact with the user, draw more things on the screen, respond to those button clicks. Meanwhile, thread 2 is handling download data task async. Now, when download data task async finishes, it actually shouts back to thread 1, and it says, hey, I'm all done. You're back up. And thread 1 swoops back in and continues running the method. Now, computers run on 1s and 0s. These threads aren't actually talking to each other. They're using what's called a synchronization context. We won't jump too deep into synchronization context today, but just know if you have an app that has a UI, you're going to have a synchronization context, and that synchronization context, that's actually what handles these threads handing off to each other. So thread 2 has gone to synchronization context and told it that it's all done. Synchronization context asked, OK, great. Well, which thread spun you up? And thread 2 said, I was spun up by thread 1. So that's how we got back here, where thread 1 continues on running the method. So not too bad, but let's get that cursor off the screen there. Much better. But to really understand what's going on with async and await, we got to peek under the covers. We got to go check out the intermediate language. Now, if you've never heard of intermediate language, this is the first step in what your compiler turns your code into. So when you click compile, your C# code boils down first into IL. You might have also heard this called, let's see, IL, MSIL for Microsoft Intermediate Language. It's all the same thing. And the reason this exists, it's pretty cool, because every .NET language runs on top of the same IL. So in theory, that same method we wrote in C#, when you click compile, would boil down into the same IL as the same code if we wrote it in F# or VB. Now, I've never tried that, but in theory, that's how it should work. And so intermediate language is kind of like this Rosetta Stone in the .NET world, because if you can read and understand it, you can translate it back up into whatever, F#, C#, VB. So back to read data from URL. Here is what it looks like in IL. Now, the first thing I want to point out to you is this is a class. We didn't write a class, but the compiler generated a class when boiling down our code into the IL. So we have this private sealed class, read data from URL, and it inherits from iasync state machine. Now, just something to note, this class adds about 100 bytes overhead. So every time you use that async keyword, you're going to be generating one of these classes behind the scenes, thanks to the compiler. And yeah, it adds about 100 bytes, but it's 2018. 100 bytes, I don't know. Maybe you're doing some IoT stuff where that matters, but probably very few of us in this room need to worry about 100 bytes too much. The next thing is, all those variables in our method, all those local variables have now become private fields. But they still look the same. So we still see we have private string data, private byte array result, private web client WC, and then public string URL. That one's public because, if you remember, that was the parameter we passed into our method. And they look a little funny. The compiler adds in these angle brackets and some numbers to them. And it just does that to make sure that they're always unique variables, because the compiler's not going to know what we name our variables. So it slaps a couple numbers and letters on it to make sure it's always unique. But at the end of the day, we can still read that. It still says data. It still says results, so not too bad. And then the last thing we get, and probably the most important thing, is move next. Now, this is what always confounded me when I first started out with async and await, because I would see move next in all my stack traces, and I had no idea what it meant. And I'm looking at my stack trace, and I'm like, I didn't write that code. Where did this code come from? Well, turns out it's compiler generated. And this is what move next looks like. Move next is essentially a giant switch statement. And you get a case inside of this switch every time you use the await keyword. So if you never use the await keyword inside of an async method, well, you shouldn't use the async keyword in the first place, but you would only have one case. And then for this one, let's bring that back, we get two cases because we use the await keyword once. So let's zoom in and check this out. So case 0, just like the code we wrote, we have WC, where we new up the web client, and then we call download data task async. And then the thread returns. So this is how we freed up thread 1, because thread 1 hits this return statement. But before it does, thread 1 increments that variable PC to 1. And it increments that because when that background thread is done running download data task async, it's going to call back to the calling thread, which was thread 1 in this case. And then because PC is now 1, it's going to jump back into case 1. And then this is where that calling thread comes back in, continues running the method. That's where we get the result from download data task async. We turn that byte array into a string and run that method called load data. Bear with me. Sorry, my computer likes to do this sometimes. I'll try to make sure the slides are always up and not the background. But probably the most important part of move next is this right here. Every single move next method is wrapped inside of a try catch block. Now, I didn't write a try catch block in my code, but move next does it automatically. And the reason why this is the most important part is because if any of those lines of code throws an exception, that exception's caught here. It's not actually thrown back to me as the developer unless we've used the await keyword. So think about, you know that warning you see sometimes when you say task.run, but you don't await it, or you have an async task method that you don't await, and you get the little squiggle, and you get the compiler warning. It's like, hey, you probably shouldn't do this. But the compiler warning just says something along the lines of, you shouldn't do it because this code's not going to execute synchronously. But really why you shouldn't do it is because if that code throws an exception, that exception's trapped. It's trapped in here forever, and it only gets rethrown if we had used the await keyword, or if we've used .wait or .result, but we'll talk about those in a little bit. So every move next method, giant switch statement, that's totally wrapped in try catch, and that exception, if it's caught, is only rethrown if we've awaited that async task method. Okay, so quick review. Async keywords add about 100 bytes to our app size. Now, again, 100 bytes, what's 100 bytes? But as you start to add more and more, your app size will get just a little bit bigger and bigger, and that's because every async method becomes a class. Make sure we await every method. You know, that await keyword, that exists for a good reason. Try not to do any fire and forget, because if you do, those non-awaited async methods or non-awaited tasks, even if you just do task.run and you don't await it, those are going to be hiding your exceptions. That's what got me. That was where I found myself one night staring at my code going, there's no way that my app could get into this state. I'm looking at the code right here. There's no way that the app could be doing this, and it was because I wasn't awaiting my async methods. Okay, so now that we're all async and await experts, I want to fix some code. I have with me a sample app today, and like I mentioned earlier, my background's in mobile. I used to actually work for Xamarin. That's how I ended up at Microsoft when they acquired us a couple years ago. But I have a pretty simple app here, and this is an app that I use to read the news every day, and specifically it's reading Hacker News. Hacker News is just a really cool news website where you can get all the latest, greatest tech stories, and so I like to wake up in the morning, I launch my Hacker News app, and super simple, I could do a pull to refresh. It's going to go out, hit the Hacker News API, bring back the latest stories, and just like you'd expect, if I tap any of these stories, well then I can read them. So behind me is the source code, and I have this class here. This is my view model. So in Xamarin, we're really big on MVVM everything, and so we'll be checking out this code in the view model today. And this is what we're going to fix up. Now, don't worry about memorizing anything we're talking about, because like I said, this code is all open source. It's on that link that we shared with you earlier. If you didn't grab that link earlier, I'll give you one more chance before we all leave, so don't worry about that either. But what we have here, we have bad async and await practices. This is what we're going to go through today together. We're going to fix this up, clean it up. But there's also good async and await practices. This is one where we've already finished cleaning it up, and that's up on GitHub. It's already finished for you, so don't worry about memorizing anything, because you can always reference that later. All right, so let's get into it. So we have a to-do refactor right here, and the first one is because we're calling this execute refresh command, and this is a method. Let's bring up some IntelliSense here. So this is a method that returns a task. And just like we chatted about a minute ago, we get that little squiggle underneath it. We kind of get this warning that says the code's just going to continue unless we use await. Unfortunately, it doesn't mention anything about not rethrowing the task. And that's what really matters to us, because you might think exceptions are a bad thing, but they're a good thing. We want exceptions. We want to know where our code's broken, so we can either handle the exception gracefully or we can fix it. The last thing we want to do is ship this to production with bugs in it. So what do we do here? Well, it says the call's not awaited, so it seems like the obvious answer is to say await, but we can't do that because we're in the constructor, and constructors can't use async and await, and that's how .NET made it, and rightfully so, because constructors are just meant to initialize. They're essentially meant to spin up an object, allocate some memory for it, maybe assign some variables, but you're never supposed to do anything async and await in the constructor. And so that's why, well, we'll never be able to do something like this in C#. So what are our other options? Well, something we could do, we can have an async void method that calls execute refresh command. And we could call this in our constructor. Now, I already see a couple of you cringing, because what are we told, right? Like, never use async void. And what did we just do? Well, we spun up an async void method. Now, in this specific case, this is actually a totally valid use of async void, because refresh is going to kick off. And inside of this method called refresh, that's where we execute, or we call the execute refresh command method, which is awaitable. And so we are still awaiting it here. If execute refresh command does throw an error, we have that await keyword. That error will get rethrown, or that exception will get rethrown. Now why is async void actually bad? That's something I always ask myself, because everybody says don't do it. And when I say why, they're like, oh, well, the only reason it exists is for event handlers and button clicks. That's what it's meant for. And it's like, okay, yeah, but why is it bad? So the reason this is bad is, let's see if we can zoom in on that IntelliSense there. So check out what that IntelliSense says. Let's pretend we didn't just write that async void method right below the next line. Let's pretend that exists in a different class. Maybe my coworker wrote this in a different class. I'm calling it from my code. And I'm just looking at IntelliSense, and IntelliSense tells me this just returns a void. So to me, I say, OK, great. So that means when I go to write some code down here, maybe I want to, let's see, I can, what was that called? My top story list. Maybe I start initializing my top story list, and I start working on some code down here. And since that's a list, I start adding stories to it, all because I assume this method is already completed. Because when I looked at IntelliSense, it just said void. But in actuality, this execute refresh command task, that method, is still running. And so who knows what's going to happen right here when I'm starting to initialize my story list and add some stories to it. That task on the different thread could also be doing the same. We could be butting heads. And this is where we're going to get some weird things happening in our code because of that async void method. So there's one reason why you shouldn't use an async void method. The other reason, actually, let's keep that code there for this. Another good reason, or another bad reason, I guess, why we shouldn't use async void is, let's say we want to catch an exception that pops up. system.exception, and we'll just say do something, because that's what we do in our production code. Anyways, this try catch block will not catch any errors that happen inside of refresh. This is really getting to the reason why async void's bad. Because what happens is this refresh method gets called, and immediately comes down here, kicks off execute refresh command, and then the thread that called refresh is now free to continue. And so by the time any exceptions may or may not happen here, we've already escaped out of this try catch block. We're long gone. And so this was another thing that got me was, I'm looking at my code and I'm like, this doesn't make any sense because refresh is inside of try catch. Why isn't the catch block catching it? Well, that's why, because async voids just continue on. They don't actually wait for that method to finish. So long story short, yeah, I agree. We should try to avoid async void methods. So, well, what's that leave us with then? Because we still want to kick off this execute refresh command. And the reason I want to kick this off in the constructor is this is the method that goes and gets the new stories from Hacker News API. And I don't want the user to have to pull to refresh the first time. I just want them to launch the app and see the list of the stories. So I put something together. This is an extension method that I made in collaboration with another MVP, John Thoreau. And this is called Safe Fire and Forget. So let's take a look at what Safe Fire and Forget looks like. Now, it is async void. It's an extension method on task. And we can pass in an action to handle an exception. We can set what captured context we want to continue on. We'll talk about that and how that works in a minute. But what's nice about here is that task that we call inside of Safe Fire and Forget, it's still awaited. So if that does throw an exception, we'll still catch it, we'll still get it. That exception's not gone forever inside of that task. And down here, the default for on exception, it'll just rethrow it. Or we can pass in a little bit of an exception handler. So the way this ends up looking is, let's see, I can pass in on exception. And this is just an action that'll handle that exception if it pops up. And so maybe we want to say something like console write line and print out the message, so at least we're aware of it. So that's Safe Fire and Forget. And this is actually something, this is hot off the presses. I actually just put this inside of a NuGet package today. Got a little inspired this morning. So we can actually find this on NuGet if you want to check it out. Again, this code's all open source if you just want to come in here and copy paste it. But it is up on NuGet. The link to it is also on that landing page if you want to go and try it out. So again, we have this async task method. We don't care about when it finishes. So we called Safe Fire and Forget. And if we had more code under here, this code will execute almost immediately. But we'll just say immediately. So we don't wait for that task to finish. It's still safe. We still handle all the exceptions. Happy days. All right, done. Now, down here, we have another to-do, and this one is kind of similar. We use commands a lot inside of MVVM, and if you're not familiar with MVVM, don't worry about it. This will only be a second. But what a command is, it's a way for the view to communicate with the view model. Commands are expected to be fire and forget, but check out that IntelliSense. Command takes in an action. What do actions always return? They return void. So by saying async with the empty parentheses, this is now an anonymous async void method. So also not great. But in that same NuGet package, I went ahead and created something called async command. Boop. There we go. And now we can just call that same method right here. And it also has this same sort of exception handling. So if we do want something to happen, if an exception's thrown, hopefully it's not, we can still do, say, like a console.writeLine to take care of that. All right. So let's keep jamming. Down here, we have another to-do, and we're calling another async task method. This actually returns a bool. So this could be, well, we're saying .wait, so we can't return the bool yet. But we are using .wait. Now, let's see, how do I say this? Never, 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 never use .wait. Don't use it. The reason .wait is bad is because it doesn't free up the calling thread. So if we think about that earlier example where, say, thread 1, let's say thread 1 kicks off, thread 1 comes in here, kicks off execute refresh command, then here, when we hit .wait, this will actually kick it off, well, most of the times, kick it off on another thread. So let's say thread 2 is running set is refreshing, but while thread 2 is running, it's holding on to thread 1. It tells thread 1, it says, you stay right here. And so now, we've tied up 2 threads. Thread 1 is locked. If the user goes to tap on the screen, scroll, it's going to be frozen. And even if this wasn't thread 1, even if it wasn't the main thread, we'd still be tying up 2 background threads. So .wait's never good. And because we're in an async task method, this one's easy. We can just say await. Now, let's pretend like we're not in an async task method. Let's say we just can't use the await keyword. Sometimes we still have to write some synchronous code, and that's getting more and more rare nowadays, but sometimes we have to. So what do we do then? Well, we can actually replace .wait with getAwait or getResult. GetAwait or getResult, it does the same thing as .wait. It'll still hold on to the calling thread. So when thread 1 hits here, thread 1's still going to be locked up. But the reason getAwait or getResult is better is when it comes to exception handling. So if this set is refreshing method throws an exception, and we were using .wait throws what's called an aggregate exception. And if you've never seen those, it's an exception that holds exceptions. And what's tough about that is on the top level, you're not going to see your code in your stack trace. With the aggregate exceptions, you got to dig deeper into it. If you've seen them before and you know how to navigate them, you can find your code. But they're a pain. GetAwait or getResult throws your exception. It returns back your stack trace with your code. It still does the same thing as .wait. It still runs synchronously. It'll still lock the calling thread. So it's still not great to use unless we have to write synchronous code. But it's better than .wait because our stack trace that we get back will actually be our code. And something that's also cool with getAwait or getResult is, let's say, is completed here. So like I mentioned a minute ago, this method actually returns a bool. So I can await it, and I can get that bool back. But again, if we have to write synchronous code, you're probably thinking to yourself, well, that's where you would use .result. Never, 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 never use .result. I wish .result didn't exist. I wish .wait didn't exist. I was actually talking with the .NET team the other day. I was like, can't we just deprecate these? And they're like, no, we've gone too far. But what we can do instead of .result, getAwait or getResult. GetAwait or getResult not only replaces .wait, it also replaces .result because it does the same thing. GetAwait or getResult, if the task does return something inside of it, it'll still unwrap that, and you get the better exception handling because just like .wait, .result likes to throw those aggregate exceptions. So when you go back to the office on Monday and you're flipping through some code, if you see .wait anywhere, that's a code smell. If you see .result anywhere, that's a code smell. Immediately, change it with .await or .getResult. Happy days. So let's go ahead and clean that up because we don't want this running synchronously. We're in an async task method. And then, let's see, down here, same, so we'll just go ahead and await that too. Done and done. Cool. All right, next method. So this next method, get top stories. This is what actually goes out to the Hacker News API, gets the top 20 stories for me so that I can view them in my app. So what are we looking at here? We initialize our list. We first get the top story IDs because, well, that's how Hacker News' API works. You need to get the IDs of the story first. And then we get the number of stories we want. Then we actually get the real story and add them to the list. Now, aside from all being serial and not running in parallel, what else is wrong with this? Because it looks pretty good. We're using the await keyword. And how can we make this better? Well, like we got a sneak peek of earlier when we saw save, fire, and forget, we can take advantage of configure await false. Now, what is that? How does that work? So let's again picture thread 1 comes into this method. Thread 1 news up our top story list. Thread 1 initializes this top story IDs variable. And then thread 1, or sorry, another thread, so we'll say thread 2 goes and gets the top story IDs. Now, when thread 2 is done, if we don't have configure await false right here, thread 2 goes back to the synchronization context, says, hey, I'm all done. Synchronization context says, great. What thread kicked you off? It goes, thread 1 kicked me off. Synchronization context goes, all right, thread 1, you're back up. And that's how thread 1 ends up running this method again, or continues running this method. But if we have configure await false here, same idea. Let's say thread 1 comes in here, does all that stuff. Thread 2 runs get top story IDs. But now, with configure await false, thread 2 is going to go back to the synchronization context and say, hey, I'm all done. Synchronization context goes, OK, great. Who called you? And he goes, doesn't matter. I don't care. Synchronization context goes, great. And it just grabs whatever thread is available to continue on. So thread 1 doesn't continue on here. This could be thread 12. This could be thread 17. Whatever available thread there is in the thread pool, it grabs it. Now, why is this important? Why is this cool? Well, we were just talking about thread 1. Thread 1 interacts with the users. That's our main thread. That's our UI thread. Let's say the user's just slamming our app. It's just scrolling on the screen or clicking a bunch of buttons. Well, if we had configure await, now I should show you this too, because there's also configure await true, but that's just the default. So if you don't put anything there, you get configure await true for free. So if this was configure await true, and this thread 2 was done, tells the synchronization context to go grab thread 1, well, what if thread 1's busy? What if thread 1's busy updating the UI because the user's scrolling for something or clicking buttons, or maybe it's a game and they're interacting with it? Well, we have to wait till thread 1's available for thread 1 to jump back in and continue running this method. So we're just kind of sitting here idle. Now, if you don't care about returning to the calling thread, which for me, my rule of thumb, if I'm in the service layer of my app, or like here we are in MVVM in my view model, I put configure await false everywhere in those, because this code's never going to interact with the UI. I don't really care if I ever go back to the UI thread or the calling thread. So we can actually add configure await false here and make our code a little bit better, a little bit faster. And the same story is true down here. So we'll slap a configure await false on there. All right. Now, a couple more refactors. We're almost done. Home stretch. Actually, we haven't fixed it yet. Here we go. OK, so we have a method called getTopStoryIDs. This method returns a task of type list of type string. Well, all this method's doing is calling this method down here, getDataObjectFromAPI, because, well, this is the method that's interacting with the API. But look at what getDataObjectFromAPI returns. It's the same thing. It's a task of type list of type string. So what we can actually do here, we can get rid of that async keyword, we can get rid of await, and we can just return the task. Now, it feels a little weird. It looks a little uncomfortable, but this is so much better. We got rid of that async keyword. We saved the compiler from generating that compiler-generated class. We also don't have any more await where we're having the context switching between threads. So again, our code just got a little better. App size got just a little bit smaller, about 100 bytes smaller, and a little bit faster, because now we're not switching threads when we come in here to kick this off. So along with .wait, along with .result, if you ever see a method that only uses the await keyword in that return statement, rip it out. That should be another code smell to you, because you don't need it. Okay, last one. This is another one where we're getting the story. So we pass in the story ID, we check to see if it's null, and then we hit the API if it's not. And just like we just talked about, right? This is an async method, and we're only using the await keyword inside of the return statement. So, well, easy, right? We just learned this. Rip that out, rip that out. This will compile, but this is a trick question, because we actually want to keep that await keyword there in this specific case. So return await should be a code smell, but if we're inside of a try catch block, let's see. Actually, let's keep that off. So if we're inside of this try catch block, if we just return a task, well, we're going to exit this method right away. We're not waiting for this task to finish. We're jumping out right away. The code's moved on, and we've exited this try catch block. So this will never, ever catch an exception that happens here. And so this is one of those cases where, yeah, return await is kind of a code smell, but here we actually do want to await this so that we could handle any exceptions that pop up here. So let's call that done, because that was a trick question, but there actually is something cool I do want to show you on this. And that something cool is called a ValueTask. Now, ValueTask is this is like the new hotness. ValueTask is coming out in .NET Standard 2.1. And what ValueTask is good for is, look at this code right here. If that string is null or white space, we just return. We never hit the await keyword. So what's nice with ValueTask is if you have a method where what I'll call the hot path. So if this is the path that happens probably, let's say, 90, 95, 99% of the time, if 99% of the time we're never going to hit the await keyword, we can take advantage of ValueTask. And just like the name implies, the difference between ValueTask and task is ValueTask, it lives in the stack in your memory, whereas a task is a reference type that lives in your heap. And so if you think back to your data structures days and your algorithm books, putting something in the heap is expensive because it gets indexed. It's really quick to retrieve it, but it's expensive to put it in there. So if we don't actually need the benefits of a task, we can take advantage of ValueTask. But again, make sure that it's only if on your hot path, where 90, 95% of the time you're not going to hit the await keyword, then we can take advantage of ValueTask. So that's something kind of cool. And actually, the way I'm actually able to have this in my app right now is it lives in a NuGet package. So in system.threading.tasks.extensions, you can play around with ValueTask today. It is coming out in .NET Standard 2.1. So you can either check out the NuGet package or wait a little bit until 2.1 comes out and play around with it. All right. So, quick review. Async await best practices. Never use .wait, never use .result. If you have to write synchronous code, get await or get result every time. It does the same thing. You get better exception handling. But ideally, we just want to use the await keyword. So if we can, we should use await. If we can't, get await or get result. Fire and forget tasks. Try not to do them. Sometimes we have to. And if you do, check out this save fire and forget method that I wrote for you. It's just an extension on top of task. Feel free to take it, slap it into your code. Or like I mentioned, it is in a NuGet package that I also called async and await best practices. Just made that for you guys this morning, so it's hot off the presses. Definitely open to any feedback if you guys want to try it out today, and let me know. If you're going to do some MVVM stuff, async commands, you can take advantage of that iasync command. That's also in this async and await best practices NuGet package. Feel free to check it out. Like I said, just push that up today. Bits hot off the presses. Avoid return await. Return await should be another code smell for you now. It's not always bad, though, because if you're inside of a try-catch block, or if you're inside one of those using blocks, the thing that disposes your object when it's done, keep that await keyword. That's coming from experience. When I first learned about this whole return await thing, I went through my code and I ripped it all out everywhere, and I was like, this is beautiful. My code's gonna be so much better. And all of a sudden, I kept getting this weird error, and it's because I was returning await inside of a using block. And if you don't await for the task to finish, well, we exited the method right away, my object got disposed, and then weird things start happening. So try to avoid it unless you're inside of a try-catch block or a using block. Configure await false. Utilize this as much as you can. Probably 9 times out of 10, at least in my experience, you don't ever have to return to the calling thread. Typically, if I'm writing code that touches the UI or touches the view, that's when I will not use configure await false. That's good configure await true territory. But configure await false, if we're in our service layer or view model layer, anything that's never going to interact with the UI, or just it doesn't matter what thread we return to, take advantage of it. And ValueTask. Like I said, this is pretty hot off the presses. It's available for you in this NuGet package. I've got all those NuGet packages linked to you in that page at the bottom of the slides. So feel free to check it out, but try not to abuse it. It is a little bit different than Task. I included the blog post that somebody at Microsoft just pushed out just a couple days ago about ValueTask versus Task, what's better, why is it good, why is it bad. So it does behave a little bit differently than Task. So make sure to check out that blog post before necessarily putting in your code, just to make sure we don't abuse it. All right. Like I said, you get one more chance to take a picture of this link if you haven't already. This is where you can get all the resources for today. So all that code demos, that's all open source. That's all on GitHub. The save, fire, and forget NuGet packages, the async command NuGet packages, those are all open source on GitHub. They're all linked on that page. You can find the slides there. You can find my contact information there. If you want to reach out to me, more than happy to chat. I love talking about this stuff. And thank you for coming. Cool. So it looks like we have some time for questions. If anybody has a question, or if you want to take off, feel free to take off too. Yeah, please. So wait 1 second for the microphone. I didn't know we had a mic. Thanks.
Do you have some Roston analyzers that can be used to detect those smells?
Oh. So that was actually something I was chatting with the .NET team about, because I was like, wouldn't it be cool if we could have a setting in our code that said something like, make configure await false the default? And for our whole project, it's the default, because in my experience, I use configure await false probably for 99% of the time. It'd be nice if I didn't have to write it 99% of the time. The answer I got was no, but it's something that I at least brought to them and they're interested in learning about. But yeah, if there's anything else you're interested that we could add to the Roslyn compiler or analyzer, feel free to shoot me a message, and I don't mind forwarding it on. Good question. What else? Yeah, and 1 sec while we get the microphone to you. How much time do we have? Till 4:50?
Yeah.
Is that right? OK, so about 7 minutes.
So is there a point of using async await if somebody is just writing web API?
Writing a web API. So that one's tough. So a lot of stuff we were talking about today was focused on things that have synchronization contexts. If there's no UI, you might, well, we'll say you might not have a synchronization context. Now, that being said, I'm definitely not an expert in web and backend development. Like, I've made some APIs, but do I know as much about it as I do about mobile? No, but I guess my answer to your question is I don't know, but I have heard folks say that you can end up abusing async and await. I've heard stories where you can spin up way more threads than you have to, and that ends up putting more load on your system. But we'll say ask an expert. And actually, speaking of Ask the Experts, there is an Ask the Expert booth I'll probably swing by after this if anybody else wants to chat face-to-face, but maybe we can ping a couple of those guys out there and find out for you. Thanks. Good question, though.
Thank you.
Awesome. What else?
A question for this, like configure await false. Is it necessary that it needs to return to the same thread or only to the thread when the synchronization context is there? What I mean, if you call it once with async false, the next time do I really have to edit it there? Or once the synchronization context is not there, it's not relevant. So I'm interested to call this one only if I know I'm doing a call from GUI thread.
So that's a good question. And so if we look at, let's see. So like this method right here where we call await configure await false. So await configure await false. So my understanding is right here, we'll just continue on with whatever thread. But here, if we didn't say configure await false again, like let's say we continued on with let's say thread 7. Thread 7's running this code. Thread 8 goes to run this code. I believe you would still return back to thread 7. So that's why I just keep using it. Even if that's not the case, in my opinion, it's always better to be safe than sorry. So that's why I just pepper configure await false everywhere.
Okay, thanks.
Say that one more time. Actually, can we get the microphone up here? Sure.
If you want to set a property that will change the UI with the data binding, you have to do that on the UI thread. So if you configure
if you wanted to return back to some code that updates the UI.
So you have to think about that.
Yeah, so that's something like, so let's pretend like top story list actually updated something on the UI or needed to be on the UI thread. Yeah, if we called configure await false here, but maybe tried to make this configure await true, this still would not return back to the UI thread. So I think what you're pointing out is don't get too overzealous if you know at some point in your method you need to get back to the UI thread. Good point.
Do you maybe have a best practice how to handle shared resources, like the entity framework context, for example? Often you have the problem, for example, considering configure await false, and then you also have async methods of entity framework, but also in other cases that you need somehow to synchronize it. And I so far do it with a semaphore slim, for example, but do you have maybe another best practice what you would recommend?
I don't. And again, that's just because I kind of live in the mobile world, so I haven't worked too much with Entity Framework. But I think that is a great question. If you don't mind, stick around, and I'd love to get your contact info, and I can try and ask a couple folks on the team about it.
Okay.
Thank you.
Yep.
We got about a minute left.
Anyone else?
All right. Well, thanks, everybody, for coming out.